Hey team, at this point you should have a general understanding of what a factor is. We know it's a math fact, and you've either used long division, number sense, or your list of multiples to figure it out. Now I'm going to reinforce it, give you some definitions, and show you what we can do with it. Let's go ahead and dive on in. All right. So this vocab square is to help design in order to make your knowledge of factors a little better. The definition: a factor is a number you multiply to get a whole number. And a whole number, by the way, is no decimal. Some facts and characteristics. A factor does not have a decimal. Another fact is factors always have another factor which forms a factor pair. So some examples of some factors. Let's talk about 9. 9 has factors of 1 and 9 and 3 and 3. 1 and 9 are factors. 3 and 3 are factors. All of the factors of 9 are 1, 3, 3, 9. Now, I don't need to include the 3 twice, but I just want to illustrate that a factor pair always multiplies to be 9. 1 times 9 is 9. 3 times 3 is 9. Some non-factor pairs are, for example, if I tried to do 9 and 2 times 4.5, or if I did another number. This is not going to be a factor pair. 9 divided by 2 is not a whole number, aka not a factor. Okay, that's it. Let's list out some factors of 16. So my numbers, I'm going to draw 16. It's at the top of the T-chart. And I'm going to go ahead and start with 1 and 16. This will always be the case. 1 times itself will always be 16. Now I'm going to ask myself, what is 16 divided by 2? Well, that turns out to be 8. What is 16 divided by 3? Well, if I were to do the long division, notice how 16 divided by 3 will result in a remainder. This will be 5 and 1/3. So I am not going to put 3 in my list of factors. Any number that's a decimal or a fraction is no-go. But if I go 4, it'll become 4 times 4 is 16. Notice how the distance between 2 and 8 shrunk to 0? That means all of my factors are listed. 27. Again, without even thinking, 1 and 27. I ask, is 27 divided by 2? What is that going to be? And I know it's not going to be a factor because 27 is odd, making the quotient a decimal. This is going to be 13.5. So I'm going to skip 2. I'm going to try 3. 27 divided by 3 turns out to be 9. Now, at this point, I have to check the numbers between 3 and 9. So I'm going to check 4, I'm going to check 5, I'm going to check 6, I'm going to check 7, and I'm going to check 8. Now I'm going to check these, and 27 divided by 4 is not going to work. 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 But I do have to go through the process of seeing, can 4, 5, 6, 7, or 8 make 9? So there goes my list. The factors is 60. So again, repeating the numbers, 60, I draw my T-chart, and I write 1 and 60. Let's look at the numbers of 6. Well, does 2 go into 6? Yeah. 2 times what is 6? 3, 0. 3 times what is 60? 20. Okay, let's go ahead and go 4. 60 divided by 4. If I go ahead and do long division, this is going to turn into 60 divided by 4. It goes in once. Minus 4 is 2. Bring down the next number when I repeat the process. 4 goes into 20 5 times. Notice how there's no remainder. So 4 and 15 work. Now I'm going to check the next number. I have to check the numbers between 4 and 15. I'm going to go 5. What is 60 divided by 5? Well, long division makes my life easier. 5 goes into 60 one time. Bring down my number. 5 goes into 10 twice. So my list is also going to include 5 and 12. Notice what's happening. Take a moment. We're not done. But my list is getting smaller. And what do I mean by that? I'm not talking about just the numbers, but the distance between numbers. Notice, between 4 and 15, there's 11 numbers. Between 5 and 12, there's 7 numbers. I'm almost done. I have to check between what numbers between 5 and 12 can work. Now, some of you might give a shout out. The next number that's definitely going to work is 6, because if 2 and 3 work, 6 works as well, which is going to be 10. Notice my list of numbers I have to check goes down now. I have to check the 4 numbers between 6 and 10. So I'm going to do 60 divided by 7, 60 divided by 8, and 60 divided by 9. All of these produce decimals, so my list is going to be done at 6 and 10. Because the next number would be 60 divided by 10. That would be 10 and 6, and that's a repeat. All right. This leads to tomorrow's exercise. So essentially, we got to figure out what is the greatest common factor. Now, like least common multiple, there are 3 parts to this term, aka 3 parts to this definition. The greatest is the largest common same factor number that multiplies. I broke it down. The greatest, the common, the same, and the factor, a number that multiplies. To use this, we're going to use a Venn diagram to find the common factor of 10 and 20. So watch what I do. 10, I get a T-chart. 20, I get a T-chart. This is going to be listing my factors. I'm going to go through the same process. 1 and 10 is always going to be the start, and I go next. 2, go times 5. I'm going to try the numbers between 2 and 5. So I have to try is 10 divided by 3, 10 divided by 4, and 10 divided by 5. No, and 10 divided by 5 is going to work, but notice how it's a repeat, so I do not need to write it again. That's just a signal to my brain that I'm done. I'm going to do the same thing for 20. 1 times 20 is 20. What is half of $20? Well, 10. What is 20 divided by 3. If I went ahead and did long division, 3 times 20, the closest I'm going to get is 6, minus 18 is 2. I go all around the world, and I'm going to have 6 2/3. Definitely not 3. What's after 3? 4. Oh, going to be 5. And the next number is 5, which is going to be 4. A repeat, so I can omit both of those from my list. Now, I've turned this problem. Now I have to find out the greatest common factor. Take an opportunity, and if you're doing it on paper, draw a Venn diagram, but watch how I draw it. Hug the right side and go all the way to the left. Again, hug the left side, go all the way to the right. That way we have a spot to write the shared numbers. What do they have in common? The common is the center part. Well, 1 is on both lists, 2 is on both lists, 5 is on both lists, and 10 is on both lists. What is the GCF? The greatest number in common is 10. So the GCF of 10 and 20 is 10. The greatest number that multiplies to be both of those is 10. All of this is just going to be repeated practice. So this is how I set up number 4. Remember, autopilot. I see GCF. That means T-chart. I'm going to do 36. And I'm going to do 40. 1 and 36 will start my list, and 1 and 40 will start it. Notice I haven't done any math yet. I'm just setting it up. Now, I would take the time to get the factors of 36. Ask yourself, does 2 go into 36? And it's yes. 3 works. Yes. 4 works. Yes. Does 5 work? No. Keep going. What numbers do I have to check? Between 4 and 9 is 5, 6, 7, 8. So I'm going to check 5, 6, 7, and 8. And the only ones on this list is going to be the 6. How many 6s make up 36? 6. When you get a repeat, you're done. Let me look at the next one. 40. Does 2 go into 40? Yes, it's even. What's half of 4? Well, half of 4 is 2 with a 0. Does 3 work? And the answer is 40 divided by 3 is not going to be a whole number. Keep on going. 4. How many 4s go into 40? 10. How many? Let's go to the next number. 5. How many 5s go into 40? 5 times what is 40? Well, 40 divided by 5 is 8. Okay, what numbers do I have to check? Between 5 and 8 is 6 and 7. So what I would do on my paper is check what is 40 divided by 6 and what is 40 divided by 7. And since both of those are going to end up with a fraction, my list is done. So now time to tie it all together. My GCF is going to be, notice how I always hug the right side and the left side to give myself room. What are the numbers they have in common? 1, 2, not a 3, 4, not a 6, not an 8, not a 10, not a 20, not a 40. What is the GCF of 36 and 40? Well, the GCF, the greatest common factor of 36 and 40 is 4.